In this video, I'm going to talk about the components of a vector. In the previous video, I explained that a vector is composed of magnitude and direction. And the components of a vector are related to the direction of the vector. We said that a vector could be horizontal, so in the x direction, or vertical in the y direction. However, what would occur if, let's say, in our plane of coordinates, a vector comes this way instead of a specific horizontal or vertical direction? And well, that's where components come into play. To be able to tell the direction of this vector, we need to find the angle it has with respect to one of the planes. So I'm going to call this angle theta. And that will be the direction of our vector A, with a line on top that represents that it's a vector. So to be able to obtain this, that's where components come into play. We'll separate this vector A into two different components. First the y component, then the x component. So this vector will be represented as in the x plane, x direction, ax, and in the y direction, ay. So in other words, we're making two new vectors pretty much. This is our ay, this is our ax. And the vector we wanted is a going this way. So these are just representations of our vector a in that respective plane. So you can project it there. It's a projection of the vector in the designated direction. Then from this you can consider that our vector a is equal to ax plus ay. And ax is equal to our vector a, but that's the magnitude of the vector in this case. That's why there's no line on top of it, times the cosine of theta, and ay is the magnitude of a times the sine of theta. An easy way to know which will have the cosine and which will have the sine is to see where the angle is placed on. So in this case, our angle theta is between the vector a and the vector ax. So that's where our cosine is going to be. In another case, if the theta, I'm going to call it alpha, this is another angle, was here, where I drew it, it will be between ay and our vector a, so the cosine would be a of y. So just to make myself clear, the component that has the angle next to it is going to have the cosine of that angle. So again, in this case, ax is closest to theta right here, so it will be the cosine of theta for that component. But we still don't have the angle, so the way to you still solve this is that the magnitude of a is going to be equal to the square root of ax squared plus ay squared. And these are all magnitudes again. So that's how you would find first the value of a, or the magnitude of a. To find the direction, you would have to do the tangent of theta, which would be ay over ax. So the sine over the cosine. That is our second formula. And well, those are the components of a vector. Thank you for watching this video. I hope you liked it and found it useful. And if you did, please be sure to give it a like and subscribe for more videos.